Hi everyone, welcome back to our final new graphing of quadratics video. Thanks for tuning in today. And this video will probably be a little bit on the shorter side. I'm sure you're happy to hear that. But before we get into the new material, I wanted to take a bit of time to review where we've been so far. So on our first day of graphing, when we were graphing in vertex form, we said that we look for translations to find the vertex. We always want to find the vertex when we're graphing a parabola. And on the first day, it was very easy. We simply looked at what was going on inside the parentheses and after the parentheses. And as a few of you have realized, you can simply switch the inside number and keep the outside number, and that automatically gives you your vertex, excuse me. So that's not too bad. On our last lesson, we talked about this thing called intercept form. And the great thing about intercept form is that we were very quickly able to get our x-intercepts. Okay? We look at what's in the parentheses, we switch those signs, and we got x-intercepts of 2, 0, and negative 8, 0. But that wasn't the vertex, and this is really all about finding the vertex. And in our last lesson, we learned that if we wanted to find the vertex, the formula that we had to use was x equals p plus q divided by 2. We had to use those values 2 and negative 8. We had to put those in and find the vertex that way. So it was a bit of a longer process, and we actually said that when we're in intercept form, finding the vertex is probably the hardest thing to do. Now for today's lesson, we're going to be looking at a third and final new form, and that form is called standard form. Now, if I look at just the equations and try to compare, one thing that I notice about standard form is that there are absolutely no parentheses in standard form at all. And that's what makes it stand out. And that makes the equation itself look very nice, but what it also means is that we're not going to get as much free information in that form. And especially given that our goal is to find the vertex, it means we're going to have to work a little bit harder. Fortunately, when we're in standard form, there is a formula to use there as well. And that's going to be today's objective, finding the vertex and graphing an equation in standard form. Now, we have our standard form up there. We start to bring letters in. We call standard form y equals ax squared plus bx plus c. And in that form, a, b, and c are all going to be some numbers. Okay? We don't know what numbers they are until we see the equation. But those numbers are going to be how we find the vertex. And the magical formula, super important, we're going to hear about this a lot. To find the vertex, we're going to say that x is equal to negative b over 2a. Again, a and b are just numbers that we're going to be pulling from that original equation. Once we have that x value in step 1, step 2 is pretty straightforward. We find the y value of the vertex by substituting that x value into the original equation. That said, let's go ahead and try a couple of problems. Our first one, we've got y equals 3x squared plus 18x plus 5. I always like to start by writing down what the values of a, b, and c are. So those are my coefficients. So a is 3, b is 18, c will be 5. And for those of you thinking if this is the same a value that we had before that tells us that the graph is going to open up, it is. This graph will open up once we get done with it. So we've got 3, 18, and 5 for our values. Step 1, we're going to use the formula from the previous page, which is negative b over 2a to find the vertex x value. So if I look at negative b, that would be negative 18. Down at the bottom, 2 times a is 3. That gives me negative 18 divided by 6, and that leaves me with negative 3. So for my vertex, I already know that the x value will be negative 3. And how do I find the y value? Well, I simply substitute that number in, substitute that negative 3 all the way back into the original equation to find y. Remember that when we're doing that, that -3 does need to go in for each of the x's. And now we'll just look at order of operations. I need to do my parentheses first. -3 squared is 9. And now I can go ahead and do some multiplying. 3 times 9 is 27. 18 times -3 is -54. And now I'm just adding those numbers together. 27 plus -54 plus 5 will give me a final answer there of -22. That represents the y value, and that goes in for my vertex. And that is how we find the vertex in standard form. Let's take a look at another one. Now we've got y equals 2x squared minus 12x plus 13. We'll go through the steps again. Just as in the previous problem, the first thing that I want to do is identify what a, b, and c values are. A is 2, b is -12, and c is 13. So step 1. I will use my formula x equals -b over 2a to find the vertex x value. Now, in this case, b is already -12, so this is important. If b is already -12, and I go into the formula, which adds another negative into it, now b is going to turn back positive. Okay? So that negative sign there is always going to change the sign. Our a value is 2. Down at the bottom there, 2 times 2 is 4. And 12 divided by 4 gives me 3. That tells me that the x value of my vertex is 3. And all I need to do now is substitute that 3 back in to find the y value. Again, always work on your exponents first. 3 squared is 9. We've got 18 minus 36 plus 13. And if I work that through, that's going to give me an answer of -5. That's my y value. So my vertex here is the ordered pair 3, -5. Now, one thing to note, if you have a graphing calculator at home, you are able to put this entire line into your graphic calculator. Make sure you use parentheses, but if you do that properly, then you will get the same answer that we did in a few less steps. We'll finish this video with you trying a problem here, so go ahead and pause the video and run this one through. Note, f of x and y are the same thing, so don't be bothered by the f of x. And now one thing that sometimes students struggle with here, I'm making sure to get my negative there on the b value, is, well, what's the value of a when I don't see a number there? But remember, when we have just an x or just an x squared, the implied coefficient out front is a 1. So the x squared really means 1x squared. So my a value here is 1. Okay? You will see that a lot, so make sure you remember that. Going back into my normal process then, I'll start with using x equals -b over 2a. This is another one of those situations where b was already negative, so -b will turn back to positive. A was 1, so we have 2 divided by 2, which is 1. That's the x value of my vertex. And now I'll go in with that 1 to find the y value. I'll use some notation here. I'm going to use f of 1 because I am plugging 1 in, and that's what f of 1 means. but the math is all the same. Exponents first, 1 squared is 1. So I have 1 minus 2 plus 5. That's going to give me an answer of 4, and that is the y value for this vertex, 1 comma 4. Hopefully, having watched this video, you will now feel confident in finding the vertex in standard form using the formula x equals negative b over 2a. As always, if you have questions on anything, please let me know, and we'll see you for the next class.